be solving more trigonometric equations. Now, we've already done this a little bit. We did that before we started practicing for the SOL. When I would give you some real basic equations, and you had to find out what the angle was that was going to satisfy it. So let's look at something like example 1. Our job is going to be to solve for theta. And we need to find all values such that theta is between 0 and 2 pi. And let's do 2 cosine squared theta plus cosine theta. What shall we do? You guys, the name of the game is, we want to know what theta is. And if this is normal solving equations 101, we want to get theta by itself. The only problem with that is, I got a couple thetas. And I can't just combine them together because this is cosine squared, and that's just cosine. So we can't combine terms that aren't similar. So how can we get that cosine by, how can we isolate the cosine? Was it, divide maybe? I don't know, what we say that? Subtract what? Yeah, let's see, I think that's a good place to start. Let's subtract the 1 so that it gets to the other side. Let's see if that helps us at all. 2 cosine squared plus cosine. Now, when I subtract the 1, I can't subtract it from any of these terms again because not like terms. And then who am I left with on the right side? 0. It's usually a pretty good place to start. Set it equal to 0. All right. It's almost kind of familiar like something else that we've done before. I think I heard someone mumble it. Oh, yeah. Here's a little thought bubble for you. Think back to, like, if I said 2x squared plus x minus 1 equals 0, and you had to solve for x, and you didn't want to use the quadratic formula, how could you solve this thing? Factor it and set it equal, set each factor equal to 0. So if you had something like this, how would you factor, how would this split up? You can use slide and divide. This one is not too hard to guess and check because there's only one way you can get 1, right? So you know these back numbers have to be 1 and 1. You know somebody has to be a 2 because the only way you can get 2 is 2 and 1. It's x and x to get x squared, right? And the only question is, which one's plus and which one's minus? If I do a plus here and a minus there, I'm going to have positive 2x from the outside. I'm sorry, if I do a plus here and a minus there, I'm going to have negative 2x on the outside and a positive x on the inside. Can you visualize that? Real quick, if I put the plus here and the minus here, I'm going to have negative 2x plus x, which is going to give me negative x, not positive x. So really what I want to do is put the negative here. That's how this would factor. And you can double check by foiling it in your head real quick. That's a little thought bubble. And by the way, yeah, slide and divide would have been fine. If you want to use slide and divide because you're more comfortable with that, then you can just use it that way. Now, what you end up seeing is that this our equation is basically the same idea, except instead of x, I have cosine. So I can replace this expression with 2 cosine minus 1. and cosine plus 1. I basically use my thought bubble here to remind me how I can deal with the trigonometric stuff. Cindy, do me a favor. Take your right hand. Right hand. Yep. And judo chop Jeffrey in the back of the neck. Stay with me, Jeffrey. Factoring, dude. You can do that. You can do that. Factoring, you got it, man. You're perfectly good at factoring. Now, if we look at, now that I have it factored, okay, set each factor equal to 0. You guys don't need me to do that. Let me to the finish line. And how did we end up with those answers? All right. Set each factor equal to 0, so that gives me 2 cosine of theta minus 1 equals 0. Or cosine of theta plus 1 equals 0. All right, now what? Mm-hmm. So you guys buy that cosine theta is going to equal 1/2? Yeah. Well, Gina, how did you find out the values of theta that are going to have a cosine of 1/2? Uh-huh. Uh-huh. Into your unit circle, you're looking for an x value of 1/2 because cosine is always the x value on the unit circle. That happens up here, and it happens down here. So either theta equals pi over 3 or 5 pi over 3. Now when you go over here, what do you do with cosine of theta plus 1 equals 0? Mm-hmm. Aha, that's all over here where the x value is -1. So then here theta equals pi. Shazam! So your final answer is theta equals pi over 3, pi, or 5 pi over 3. 3 different possibilities that will solve that equation for you. Qué fácil, ¿no? Qué fácil. So really, this is just a nice combination of when we used to solve quadratic equations and when we solve basic trigonometric equations. So all we're doing is combining 2 lessons that we've already seen before, and hopefully it doesn't intimidate you too much. Now let's ramp it up just a little bit. Example D. Let's do cosine of 2 times theta equals square root 3 over 2. And again, I want all the values in between 0 and 2 pi. Now, before you jump into this, I'm going to show you 2 ways that you could do this problem. And you can decide which way you like better. Let me tell you what is dangerous to do. So if I were you, I want to write this down because I think the way I'm going to show you next will be a little easier. Some of you guys are like, oh, hey, double angle. I have double angle formulas for cosine. In fact, I have 3 to choose from. So let's just use the basic one. It says cosine squared minus sine squared equals cosine of 2 theta. Now, like I said, I would have got this out because I'm going to show you an easier way. Right? Because if I do that, then I'm left with, all right, well, what do I do now? I mean, you could try factoring it. The only trouble with that is you can only use that factor trick if the equation is set equal to 0. That does not equal 0. So, okay, maybe you want to subtract the square root of 3 over, all right, you want to subtract the square root of 3 over 2 over to the other side. Well, then, I don't know how the heck you're going to factor it. Because we haven't done anywhere you got, like, x squared minus y squared and then minus some other number. I don't know how you would try to factor that. So before you jump into the double angle formula, I would take a step back and say, maybe there's another way I can do this problem. And this is what I call, you remember when we solved those polynomial equations, and it did a little something called U substitution?
Oh, yeah.
You guys remember that? You're going to see more of that in calculus. But what I like to do in a problem like this is, what makes this thing difficult is it's 2 theta, not regular theta. Because if it's regular theta, then I can just say, oh, forget him for a second. Then I can just look for the x values in the unit circle that have a square root of 3 over 2. That's pi over 6 and 11 pi over 6, right? Kind of, sort of, maybe tomorrow. Yeah. Now, the 2 messes it up, though. Because I need 2 times some angle to give me the square root of 3 over 2. Well, what I like to do to make this thing a little easier is I'm going to replace the 2 theta with a new angle, and I'm going to call it alpha. So I'm going to let alpha equal 2 theta. And this is where I would probably start trying to think that. This is just a little trick. I call it, this time it's alpha substitution. So now, cosine of 2 theta really turns into cosine of alpha. Equals the square root of 3 over 2. Well, that's easy, Mr. Tucker. I can solve for alpha. That's unit circle 101. Square root of 3 over 2. I want an x value. That happens over here, and that happens down here. So that means alpha could equal pi over 6 or 11 pi over 6, right? Those are the 2 values in the unit circle that have an x value of square root of 3 over 2. But Mr. Tucker, I didn't want to solve for alpha. I really wanted to know what theta was supposed to equal. Well, if alpha equals pi over 6, and we said that alpha was 2 theta, you guys okay with, I'm just going to replace that alpha with the 2 theta. I swapped it back. Okay, that's not too bad. Now I need to solve for theta. Well, how do I get theta by itself? Divide by 2. That's solving equation 101. Divide this guy by 2, that means I'm going to divide these guys by 2. Theta is going to equal pi over 6 divided by 2 is pi over, no. Pretend you're dividing by a fraction. 2 over that fraction is 2 over 1, so that means you're multiplying by 1 over 2, which is going to make it pi over 12. 11 pi over 6 divided by 2. Dividing by 2 is the same as multiplying by a half. So 1 over 2 give you 11 pi over. That's vanity. Now. All right. Here's where you got to be real careful. That's not all of the answer. Looks good. Looks like we did everything right. Remember, we were supposed to find all of the values between 0 and 2 pi, right? Well, if you think about where these are on the unit circle, pi over 12, is that bigger or smaller than pi over into 6? Pi over 12 is actually just a little bit smaller. So pi over 12 would really be like barely off the x-axis. 11 pi over 12, that's almost to pi, right? So we haven't found anybody in this third and fourth quadrant. Sometimes there's going to be something in extra there, and sometimes there's not. But it's something that we've got to be wary of. Now, here's the way we find out. Think about our initial range. Let's say we wanted all the angles between 0 and 2 pi. But then the angle that we were actually trying to deal with was 2 theta. So one way you can get all the extra answers is you change this theta to 2 theta. Well, I can't just multiply him without multiplying these other guys too. So what that does is that changes my range to 4 pi. So really what I need to do is, instead of stopping here at pi over 6 and 11 pi over 6, I need to go ahead and do an extra rotation. So let me see here. The easiest. Alright, so this is the trickiest part of this all. Here's 11 pi over 6. Here's pi over 6. Well, we need to go not only just to 4 pi or to 2 pi, we need to swing all the way around to 4 pi. So that means I need to go around the circle not once, but twice. Now these are still the 2 angles that are gonna satisfy the cosine being the square root of 2. So I just need to go to the ones that are just add 2 pi to pi over 6. Now let me go need a common denominator. So 2 pi is who over 6? 2 pi is like pi over 6. 2 pi. How can I write 2 pi somebody over 6? 12 pi over 6, right? So if I add 12 pi over 6, I'm just adding 1 rotation on the pi over 6, and I get 13 pi over 6. All I did, I know you guys are like, oh man, you're out of here now. I see the look in your eyes. See it. Here's the deal. When you have a double angle here, you have to expand your window because all of your values are they're gonna end up being smaller than that would normally fit in one rotation. So you expand your window out to 4 pi. So that means when I'm looking for all the values that are going to satisfy cosine of alpha equals the square root of 3 over 2, I need to take the values that are within 2 rotations on the unit circle. This is just within 1 rotation. So my second one, I need the same angle, but I need to do it 1 rotation later. So I just add 1 rotation to pi over 6 to get 13 pi over 6. I add 1 rotation to 11 pi over 6, and that's going to give me Jeannie, look like you're about to cry. You're just like, oh, what am I doing? Look what happens here. Here's your pi over 6. Are you guys okay with the fact why we need to go not just once around the circle, but now we got to go twice?
Yeah.
Exactly. We want to know 2 pi, or we have 2 theta here, so I had to expand my window. Once you know you need to expand your window, you need to find all of the values in that window that'll give you the square root of 3 over 2 as the cosine. Well, that happens at pi over 6, no big deal. That happens at 11 pi over 6. But then you got to keep on going because that's just 1 rotation. Get the second rotation, and now I'm back here again, but I had to add 2 pi to put me in the second rotation. Yes, I have that.
So why did you do it to the pi over 6 and not the pi over 12?
How can I explain that? The best answer is because if you do it to the pi over 12, the answer will be wrong. That's it.
Is it the pi over 6 for little squiggly thingy? Not for 2. So is it not?
Oh, for alpha. I see what you're saying. Well, think about it. Alpha equals 2 theta, right? So 2 theta is supposed to be between 0 and 4 pi. So that means alpha should be between 0 and 4 pi. Theta is still going to be in between 0 and 2 pi. But alpha is going to be in between 0 and 4 pi. So we need to find all the alpha angles. These are the theta angles. This is eventually going to be the answer. We're not done yet. We're only at half of it.
Oh my god.
Something tells me I'm going to use third period video to put on the computer this one is struggling. All right. So, okay, back this up. So we buy that we need to go for 2 revolutions. The reason why we want to get the extra revolution of pi over 6 and not pi over 12 is because 2 theta is supposed to be between 0 and 4 pi. Alpha is 2 theta. So these angles are the ones that need to be between 0 and 4 pi.
Okay.
These angles down here are theta angles. These are the alpha angles. Does that help?
So is it supposed to be 3? Should I use the 3?
Yeah. Yes. Yeah. So now, these are my extra values here. Well, I can still solve them for theta the same way. Because remember that alpha was just 2 theta. So I still would divide by 2. So then I end up with 2 more angles of 13 pi over 12 or 23 pi over 12. And now I have all the solutions within one rotation. Yes. What's that? Yep. 13 pi over 6 is just pi over 6 plus 2 pi. Because in order to add these together, you need a common denominator, right? And 2 pi is really 12 pi over 2. So when you add 12 pi over 2. 2 pi, I'm just adding pi over 6 to 2 pi.
Okay.
In order to do that, I need a common denominator.
Okay.
So that means I need to write 2 pi as somebody over 6.
Okay.
So I changed the 2 to 12. 2 divided by 6 is 2. Or sorry, 12 divided by 6 is 2.
Okay.
So if you can picture this 2 pi getting changed to 12 pi over 6 plus another pi over 6 makes 13 pi over 6. Do the same thing with the 11 pi over 6. Add 12 pi over 6.
Oh, around like 4 times or like 4 times after that, added by like 4 times, or is it always added by 2 times?
You still add 2 pi because that's how you get the next revolution. Now, if you wanted to swing around one more time,
So you add another.
then you'd have to add another 2 pi. All right. So those are your 4 answers. Now, you guys realize you can always check your work, right?
Yeah.
You can plug back in and see what happens. What's up? Sure. If you plug pi over 12 back into the original equation, 2 times pi over 12 turns into pi over 6. Cosine of pi over 6, we all know is the square root of 2. Try one of those bigger angles, 23 pi over 12. We plug 23 pi over 12 into theta. 2 times 23 pi over 12 is really 23 pi over 6. Now, I know that's not a unit circle value that you're really comfortable with, but if you found 23 pi over 6, it would end up landing down here at 11 pi over 6, which the square root, or the cosine of that is the square root. And all of these values, pi over 12, 11 pi over 12, 13 pi over 12, 23 pi over 12, those are all in my original window of 0 to 2 pi. How's that? It's miraculous. Miraculous. You thought that was funky? I got one more for you. Ejemplo 3. All right. Oh, what happened to my? Oh, that's interesting. I started on the 3rd page. Whatever. There. So ejemplo 3. Let's do. This time we're solving for all values of theta. Before I was stuck between 0 and 2 pi. Now I want everybody. And let's just do 4 times the sine squared of theta minus 3. So if you write it down so you don't forget, I sent it to class and play all that. All right, so 4 sine squared minus 3 equals 0. What do you guys think is the first step here if you want to solve for theta? All right. Yeah, I'd probably add 3 both sides and then divide by 4, right? So this is gonna, you guys I can skip a step and just go straight to sine squared equals 3 over 4. You guys all right with that? How do I get rid of the squared? Square root both sides, and so now I'm down to sine equals the square root of 3 over 4. What did I forget? Plus or minus, good. And I can simplify that to the square root of 3 over 2. Hip hip hooray, we're almost there. Now, if this said find all the values between 0 and 2 pi, you could just think about your unit circle. Square root of 3 over 2 for sine, does that mean I want to be close to the x-axis or the y-axis? The y-axis. That happens here, 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 and here. So those angles, that is ugly, I know. Those angles would be, who's the one in the first quadrant? Pi over 3. Who's in the second? 2 pi over 3 in the third quadrant. 4 pi over 3 and okay. That would be the answer if they said find the values between 0 and 2 pi. But it says find all of the values of theta, which means I don't just want to swing around the circle 1 time. I don't just want to swing around twice or 3 times or 4 times. I need to swing around the circle an infinite amount of times. What on earth are we going to do?
We're just gonna find a place to stop. Yeah.
Has something to do with the period, right? You guys buy that? Obviously, we're not just going to write out all the angles for infinity. Like, that's not going to work. So we got to come up with some way to symbolize that, to represent that. Now, what you could do here's the basics behind what we're going to do, and then we're going to try to find a way to simplify it. We're going to take these 4 angles, and then we're just going to add 2 pi to it each time, right? That's the only way you're going to get these new rotations, is you add rotation to it. Well, I'm not just adding 2 pi. I need to add 2 pi as many times as I want. So we introduce this value k. And we're going to let k be any integer. All right? So one way you could write this thing, you could write this answer, you could say theta equals pi over 3 plus 2 pi k, 2 pi over 3 plus 2 pi k, 4 pi over 3 plus 2 pi k, and 5 pi over 3 plus 2 pi k. Do you understand that concept? All we're doing is I'm taking the solutions and I'm basically adding the period to it. So if I add pi over 3, this allows me to say, okay, when you add 1 revolution of the circle to it, I'll be back at pi over 3. Or if I add 2 revolutions or 3 revolutions, you can even go backwards, add a negative revolution, -2. It works for any integer k. Not quite. Because we can make it a little more simplified than that. It's kind of like the period. Same idea. Let me clean this up a little bit. Do you guys see that the values on the unit circle are going to be those guys, and these are the ones that we wanted, right? You can actually, instead of having 4 separate values of theta, you can combine some of these together. Can you see how these two, pi over 3 and 4 pi over 3, are opposite of each other? So what's the distance between pi over 3 and 4 pi over 3? Pi. It's halfway across the circle, right? And halfway through the circle is pi. So instead of writing pi over 3 plus 2 pi k and 4 pi over 3 plus 2 pi k, I can combine this together to say pi over 3 plus just pi k. Because if you think about, if k is 1, I'd be adding half a revolution. I'd be adding pi to pi over 3. That's going to put me at 4 pi over 3. So I don't need to write an extra 4 pi over 3 over here. And when I add another pi to that, it's going to put me back on the angle that's coterminal with pi over 3. It's going to keep on, it's going to alternate between these two. You can do the same thing for our other pair. So I'm just going to say, hey, that's 2 pi over 3 plus pi k. And that is the best answer. Because that's more simplified, right? So this one takes care of pi over 3 and 4 pi over 3, and the second one takes care of 2 pi over 3 and 5 pi over 3. The key there is you should look for symmetries on the unit circle. Because like if I had, sometimes you'll end up with one where like all the answers, all of them are right on the midway line. And you could just say, oh, take pi over 4 and add a quarter rotation each time. Well, what's a quarter rotation in radians? Pi over 4 would be an eighth of a rotation. Quarter rotation would be pi over 2. Good. Wrong class. That is not a question. would I mark it wrong if you wrote it the long way and not the short way? Me personally, I want you guys to be able to write it the short way, so if I took off anything, I might take off a half a point or something like that. The AP exam, I'm pretty sure that they would accept the long way, because you don't really have to simplify anything on the AP exam. Like if the answer is 1/2, and you write 3/6, they're gonna give you full credit, right? So I imagine this would be the same kind of idea. But you might have to double check it. All right. Any other questions about las notas? Okay, let me go ahead and get you started here. Well done. Cheerio.